Okay, let's continue with Blanka Novak from Hungary.
Hello everyone, my name is Blanka Novak and I'm from Hungary. Before presenting my research, I just would like to add, så kul att vara här. Jag gillar verkligen ert land och svenska köttbullar. Tack så mycket. Traditional Asian medicine has been using this herb for nearly 5,000 years. So the question might naturally arise, is there even more to it? I've tested several solutions antibacterial activity. Before, previously, there was no moderate inhibition detected against bacteria. Its importance is due to the fact that super-resistant bacteria grow and spread at an incredibly swift pace. And if that tendency continues to go on, the lethal rate, as you can tell, will reach 10 million. So that's why we call it the times after the antibiotic era. So we gotta find a solution, right? I mean, in both meanings. For I prepared a solution from the Asian herb Lycium barbarum based on my own method. In my experiments, I followed the Kirby-Bayer method. You basically suspend the solution on a solid broth. You put the exact disc containing the solution and also the control antibiotic on the plate. After incubation time, several like these black holes you can see up there, but this time not related to astronomy, represent the disappearance of the microorganism. So I measured the inhibition zone, and in the control, compared to the control, the solution's inhibition diameter was almost 2 times larger compared to the antibiotic in use today. However, we know that antibiotics are held responsible for creating an imbalance in the intestinal flora, which might lead to further severe diseases like Alzheimer's or Parkinson's disease. So that's why I've tested on good microbes, and they surprisingly grew in the solution like almost 100 times greater. So we can wrap it up like it killed the bad guy, the Pseudomonas, which creates chronic pulmonary infections and also nosocomial and iatrogenic infections, while it saved the good ones. And in the next, the samples are rich in carotenoid and polyphenols. We already know that, but the question is what's new in the solution? That's why I used HPLC. It's a high-pressure liquid chromatography. You basically inject the sample, a high-pressure pump creates a mobile phase where, let's put it this way, the components just keep swimming to hit the detector and the signals are being translated in the computer. So the high peaks you can see up there in the lilac one represent that new compounds are formed in the solution. However, I'm currently patenting it right now, so I cannot share any further details. However, to sum the never experienced results up, I used a new solution preparation method. It was effective against resistant bacteria. It was also better than the antibiotic in use today. It saved the good microbes, and also the origin of source influences not only the phytochemical composition, but also the antibacterial activity, and can also be applied with other drugs too. So I'm going to go to several competitions in next year sent by the Hungarian Association for Innovation for a World Championship. So that's why I would like to carry out in vivo experiments and a mechanism study on the efflux pump. But you might be wondering how I started this project. My aunt had been suffering from several lethal diseases involving cancer, and I wanted to help her. So that's how I found goji berry. But the sad is that she passed away during her chemotherapy due to a bacterial infection actually caused by the bacteria I'm investigating. So the sadness of her loss transformed into a motivational power to help people like her. And you, sitting in some of the rows, might have an idea whether it might be in other fields. And I highly encourage you to pursue your passion, because no matter the obstacles, it's always worth the prize. Tack för er uppmärksamhet. Ha en fantastisk dag. Thank you.
Thank you very much. Do we have some questions? Yeah.
I have two questions. My first one is, can't the bacteria become resistant to this as well?
It's a really good question. The Pseudomonas has its resistance due to a so-called drug pump identified in its cell wall. So when the medicine comes in, it actually pushes it out due to transformational changes. I've already had experiments on that. I'm concluding it right now. And the hypothesis is that it doesn't get in, but it attaches to a receptor, and that blocks the transformational changes, so the molecule stays inside. But that involves the future plans. So.
Okay, and I'm also wondering, how come it can be bad for some bacteria and not harm others?
Yeah, so it basically inhibited the growth of the Pseudomonas. So that's kind of the innovation, because antibiotics usually cause these gastrointestinal imbalances, and that's a new thing. So it has both of the effects, so we can say it's a combo. Yeah, but I'm studying that.
Okay, thank you.
Thank you so much.
Is there any other question? Just below. Maybe you can pass by the microphone. Thank you.
Do you think that with further investigation that you can use this goji berry for like different diseases?
Different diseases. It's a really good question, because Pseudomonas is a bacteria that not only creates these chronic pulmonary infections, but, for example, patients who receive chemotherapy or who are generally just laying in the hospital and they have a weakened immune system, this bacteria can invade them and create like a further infection that just makes the disease harder to treat. Like, current medications are not efficient to treat these diseases, so it might have a lot of applications due to that one, because it creates chronic iatrogenic infections.
Thank you. Is there any other question? Yeah? There?
Well, I have two questions.
Okay.
The first one, you said that it killed the bad bacteria, but about half as much or double or something.
Okay, so we measure it by the so-called inhibition diameter, which means when we suspend the bacteria on the plate after a specific amount of incubation time, so-called inhibition zones appeared. So the larger the diameter, the greater the antibacterial activity. So that's why we need a control, because we have to compare the solutions or the specific extract we are doing our study to that control. So that's how we can measure the antibacterial activity.
Okay, and then the good bacteria was a lot more.
Yes.
Could it be that the bad bacteria was killed because there was so much more good bacteria?
These are two separate studies. So the first one is with the pathogens, the bad ones that cause infections, and the second one was with the bacteria that are found in your intestines. And you need different study methods. You use different dilution degrees, and you use different solid broth composing of the similar nutrients as well. So that's two separate studies.
Okay, thank you.
Okay, any more questions? Okay, thank you very much then.
Thank you.
Thank you. Okay, so this section is over. We are going to have a guest lecturer.